So we are going to solve this differential equation by using power series method. That is, our solution y can be written as a power series in x, and here I have this written in summation notation, which let me expand for you. So here is our series in the expanded notation. That is, I let n become 0. So I have a0 times x to the power 0. That is simply a sub 0. And then I gave n the value 1. So both of them became a1 times x to the power 1. And then it just keeps on going to infinity. Okay, and this is a convergent series. So first let us work on this in a very basic manner. That is, let's not deal with the summation notation and work with just the expanded form and just taking some, so just doing the calculation to a few powers of x. So here we have y, and these a0, a1, and all these coefficients are constants. So we have the derivative of y involved and the second derivative involved. So let's just go ahead and take the derivative and the second derivative. Okay, so if I take the first derivative, what I'm going to get, this is the first derivative. A0 is a constant, so the derivative is 0. The derivative of x is 1. X square, the derivative would be 2 times x to the power 1. And subsequently, we are going to get 3a3x square, and so on and so forth. I just did the calculations and brought it back to you. Okay, now for the second derivative, what we are going to do is that we are going to go ahead and differentiate the first derivative. Okay, so here we are differentiating the first derivative. So we will have the derivative of x is how much? 1, and then we will have 3 times 2, that is 6, and then 6 times how much here? X. So let me do the calculation. And here I wrote the entire second derivative for you. So as I said, we had gone this far, 6a sub 3x, and then this would be 4 times 3, that is 12a sub 4x square, and so on and so forth. Now we are just going to do just a little algebra, because you can see y double prime, when we substitute here, we will substitute this as it is. Then with y prime, what we are going to do is this, that we shall multiply y prime by x square, as we have in the equation. And when we multiply y prime by x square, every term on the right hand side will have power on x increased by 2, and what we get is x square times y prime equals, see, everything everywhere here, the power on x increased by 2 because of multiplication by x square. And now our next step would be to multiply this equation by x as suggested in the as it appears in the differential equation here. So when we do that, we get x times y equals just this equation multiplied by x. So it's just simple distribution of x on this convergent series. And now we are just simply going to do sort of algebra 1. That is, here is the differential equation that we have to solve. And what we will do is we'll substitute all these values on the left. So if we do that, what we will have is we will have this quantity added with this quantity here. Okay, so let me bring it down here. Okay, so there we are. So we have, let's align the like powers together. Okay, so this is what we have here. Then at the end we have x times y, right? So we have that over here, okay? So what we just did was that this expression on the left hand side, we wrote it all here, okay? And now what we are going to do is this, that we are going to add these all together. So when we add these, what we will do is that we'll just combine the coefficients of like powers. So we have 2a2 is the only constant here. And for x, what we got? 6a3 plus a sub 0. So we'll write it down here. 6a3 plus a sub 0, right? And then times x. And so if we collect all these coefficients one by one, let me just do one more collection like live, and then I'll just bring them together. So here for x squared, we have how much? We have 12 times a sub 4, and this a1 will add with this a1 here. So what they together will become? 2 times a1, and that times what? X squared, or this entire quantity on the left hand side, right here, when we collected coefficients like this, I just did the calculations in the background, and so the coefficient of x squared we calculated together, and this will be that of x cube, and that's how we will proceed, towards the higher powers. And this, sorry about that, and this whole thing will become what then? This whole thing is going to become 0, okay, as in the original differential equation. So what will happen now? That right hand side is 0. So from the left hand side, if we do the comparison, each and every individual coefficient is going to become what then? 0, right? That is 2a2 will be 0, then likewise 6a3 plus a0 will be 0, and then this will be 0 as well. So let me just keep on writing it with you, or I know I can just go back and write it all up and then bring it back, but let's just do it this way if you don't mind. Okay, so there we are. This is a 0, right? And what this would do is that this will give us the values of the coefficients a's, and of course there will be a general solution, and for particular solution, for initial value problems or with initial values, we'll work with those later. So when 2a2 is 0, what does that mean right away is that a2 is 0, right? And then when 6a3 plus a0 is 0, what we will get there is that a3 equals negative. We will just solve this equation for a3. So what that will be? Negative 1 over 6 times how much? a0. Okay, and then this will give us what? That our a4 would be, that would be, just a moment, that would be again the same kind of thing. a4 equals negative, then it will be 2 over 12, and 2 over 12 is going to be 1 over 6 again, and that will be times a1. Okay, so what we have is that we have these values expressed in terms of a0 and a1, and we shall expect everything to be expressible in terms of a0 and a1. Okay, so going along like this, or what happens is this, remember this a2 is 0, so this will become 0. When this value is 0, then a5 will simply become what then? a5 is simply 0, right? And now let's come up here. Okay, so now our a6 is equal to negative 4 over 30, which would be what? When we reduce it, it will be 2 over 15, A3, right? And now we can reduce A3 further by what we had here. A3 is how much? A3 is negative 1 over 6 A0. So we will just bring that in. Okay. Just go on reducing it. Okay. So we got that. And then what will happen? 2 times 3 is 6. So this would be 1 over 15 times 3 is 45, A0, right? And then let's just stop at this term here at A7, and we can just proceed like this if we would like. So that equals A7 is negative. See, it will be 5 over 42. All right, so 5 over 42 times A sub 4. And now if you look at A sub 4, what we got is A sub 4 is negative 1 over 6 times A sub 0. So we will just bring that in, and just to reduce it, I must have put many of you to sleep already on this. Okay, but anyways, yeah, just bear with me. So here what will happen? On the top I have 5, and on the bottom 42 times 6 would be what? 240 plus 12 is 252 times A1, and so on and so forth. Okay, so now we can go ahead and bring our y here. So what we can, so let's write the value of y now as an infinite series. So what was A0? A0 we are just going to leave as it is, okay, because all the coefficients that we saw were expressible in terms of A0 and A1. So here A0 then plus A1x. This term will be out because A2 is 0. So we erase this, okay. Then for A3 what we have is we got negative 1 over 6A0, right? Okay, so yeah, let me just write it here. It should not be too complicated to do it like this. Let me know as a feedback if you don't like me writing like this. So this is negative 1 over 6A0. Likewise, A sub 4 is that this is negative 1 over 6A1. Remember, A5 is 0, so this is out. All right, for A6 we got 1 over 45x to the power 6, right? For A7 we got 5 over 252. So we got all these guys, right? And if you want, there are several ways of doing that. Collect the coefficient, just to factor A0 out and A1 out, or you can just freely assign the values to these initial conditions to get two linearly independent solutions. Okay, like say we assign A1 the value, A0 the value 1, and then A1 the value 0. What happens is we have one solution here. Let's write it as say y sub 1. So this is a 1. This is 0. And then A0 we assumed as 1. Right? A1 we gave that the value 0. Okay, so this we assumed as 1. And A1 we wrote that as 0. So this is one solution here, right? And then we can just choose like the values for A0 and A1, vice versa. That is, now let's give this the value 0 and A1 the value 1. And what this will become then is that you have a0 is 0, and you gave a1 the value 1, so we get an x, and then here a0 we took that as 0. Okay, just a moment, I'm sorry. Okay, so a0 we took that as 0. That was okay. I don't know why I did that. Then a1 is 1. Okay, then this term is going to be 0, and then a1 is 1 again. So in this manner we got two linearly independent solutions. One is this and the other one is this one. Okay, so this was the calculation done in a basic way. Now if you want, you can go ahead and do it by using the summation notation to arrive to kind of same situation as I'm going to do next. So now we are going to do the same calculation another way. Okay. So we have our y as a convergent power series, and our differential equation is what here? That is this equation. So what we would do is that we will just go ahead and write these directly in our summation notations. So if I look at if I compute my y prime, what will happen is this, that the first term differentiated will be 0, and then x to the n, when you differentiate it, what this will be is that this will be n times an to the power x minus 1, and notice this, now n is going to start at 1. All right, because the first term was 0 and we are starting with simply a1, right? Okay, now when we differentiate it again, so when we differentiate it again for y double prime, what we will have is n minus 1, or x to the n minus 1. The derivative would be n times n minus 1, and then this is a constant. Then we will have power n minus 2, and what we get is that y double prime is n times n minus 1, a n x to the n minus 2, and now our index will start from n equals 2, because the first two terms, while taking the second derivative, have become 0. Okay, so now our next step is to just go ahead and substitute these values in the differential equation. So let's do that. This takes place of the y double prime, right? This will take place of the y prime, all right? And then at the end we have this power series replace y here. Okay, so we can do this. We can distribute these powers of x inside, just like distribution over parentheses. Here we just have a really big parentheses, right? So x squared, when I multiply this quantity by x squared, what this would do is that we just have two more powers here, right? And this x, when we multiply that in, we will have x to the n plus 1 here. Okay, and let me do this here. That is simply simplify this. So here we got how much? So when we multiplied that by this here, sorry, we got x to the n plus 1. Okay, so we have the entire series written here. Now what we are going to do is that we are just going to go ahead and match the indices so that we can collect the coefficients. So we will adopt the following procedure for this. Now in order to collect the like terms, what we would do is that all these powers on x, we are going to replace them by a single variable, say k, in the following manner, that say for this portion, what I am going to, just a moment, for this portion, what I would do is that I will replace n minus 2 by k, another. So here we are going to replace n minus 2 by k, and for these guys, this one here, and then this one here. What we will do in these two cases is that replace k by n plus 1. So in here we will replace n plus 1 by k, and we'll do the same thing here. So now when we make the substitutions, then we should realize that when we replace n minus 2 by k, then n becomes k plus 2. So this quantity n will become k plus 2, n minus 1 will become then k plus 1. And here when we have n equals 2, then k will become 0, and the transformation becomes what? So again, what we have here is this has transformed to this summation, because when n is 2, k is 0, n is k plus 2, n minus 1 is k plus 1, and a sub 1 is, of course, is a k sub 2 now, and this is x to the power k. And likewise, here when n is 1, k is 2, and n is, of course, k minus 1, and we have done the substitution likewise. Now what we would do is, here you can see the summation is starting from k equals 0, here is starting from k equals 2, and here from k equals how much? 1. So we would do this, we will expand this so that we will write the terms corresponding to k equals 0 and k equals 1 first, so that this summation starts from k equals 2, and same thing here, we'll write one term in front. Let me show this to you instead of just talking. So what we did was we transformed this summation, with a new index k, to write it in this form. And now what we will have is that we are going to do this. Just a moment, I'm sorry. Okay, that is, let's expand them until their starting points match. So here what I'm going to do is I shall write this corresponding to k equals 0 first. So what that will become is, this would be a 2, this would be a 1, so whole thing becomes what? 2, and k is 0, so this will simply become a sub 2, and k is 0, so x to the 0 will become 1. So that's the first term. Then for the second term, which will correspond to k equals 1, right? So when we write k equals 1, what this will become? 2 plus 1 is 3, right? And then 1 plus 1 is 2 here, okay? And so 3 times 2, and we have k equals 1, so this will become 3, and k is 1. That means we will have only x here, okay? And then rest would be the same summation, and the only difference would be that now we are starting this summation from 2, okay? Now for this one, it's already starting at 2. What we did was we're just going to go to the highest of these 3. So this is starting at 2 already, so we are not going to do anything with this, leave it as it is. And for this one, what we would do is that we will write this with respect to k equals 1. So when we write it with respect to k equals 1, then 1 minus 1 would be what? That will be simply 0, right? And this is a 1, so the x to the power 1 is x. And then this also becomes what? This becomes, this now starts from 2, okay? And now we are able to combine them. That is, let's do this here. We will write these terms together here. then the summations together. So we have what, 2a2x plus 6a3x, okay, and then here we got these guys here, then plus how much, plus a0x, and all these are equal to what, 0, right? And now we are ready to combine the like powers of x, so let's do that. And here we have as powers on x 6a3, okay, plus a0 times x. Now in here we will just put a big bracket here, okay. So let me bring a big bracket for you here. Well, I'll just put it like this. Oh, sorry, put it like this here, okay. And then you have these quantities as coefficient of xk starting with x equals 2 in all these three summations. So what this will contribute here is, this will give us plus this quantity, right? So now we can erase this, okay, and this is going to contribute what for us, ak minus 1. So we got ak minus 1 here, and then we would just erase this portion, okay. Now notice this negative ak minus 1 will cancel this positive ak minus 1. So we can simplify it further, and so that means this is cancelled, and here this negative 1 should go away, okay. So now what we would do is that we will collect the, we'll set the coefficients of all powers of x equal to 0. So we have 2a2 because this is the only constant here, that equal to 0. Then we have 6a3 plus a0 equals 0. Now we are going to involve fractions, so let me increase the font size here, and this is going to give us what? This is simply going to give us that a3 equals negative 1 over 6, and then what, a sub 0, right? And then here we are going to start setting these equal to 0, starting with k equals 2, right? Because till x equals 1, till the power 1, we have handled that here. Now here we are going to start with x square. So here k will be 2. So k will be 2 means what? This is going to be 4, right? Times k is 2 means this is 3. So we have 3 here, and k2 means this sum will be 4, okay. Now here we have k equals 2, and 2 minus 1 would be 1, excuse me. So we will have this quantity equals 0, which gives us what? Which will give us that a4 equals, again, negative sign, okay, because when we transfer it to the other side, that will be a negative, right? And then that will be what? 2 over 12. So again, that will be 1 over 6, and now this will be 1 over 6 times a1, right? And I'm just going to do one more, then rest you will. I hope you have gotten the pattern. Many of you may not even be staying with me this far. So now when we have k equals 3, this would be 5, okay, and this would be what? K equals 3, so this sum will become 4, okay, and this would become 3 plus 2 is 5, and this has become how much? So we have k equals, what did we take k equals here? 3, so that's a 3, and here we get 3 minus 1 is 2, so this will be 0, And remember this, as in last time, this will simply give us that A5 is 0 because A2 is 0, and we can just do the rest of calculation and proceed as far as we would like to. Okay, so if you stayed with me this far, thank you very much, or let me know if you have any questions. Okay.